This is one of the largest flying creatures to ever exist on this planet. And this is a human standing next to it. About 68 million years ago, in the floodplains of what is now Texas, it was probably one of the most terrifying things in the sky. Its wingspan stretched close to 10 meters. Standing on the ground, it was almost as tall as a giraffe. Its beak alone was longer than a grown man. But most of that giant silhouette was head and neck. The body beneath was surprisingly small. This is Quetzalcoatlus, one of the largest pterosaurs that ever lived, a giant that ruled the skies alongside the dinosaurs. And I want to be careful with that word, dinosaurs, because it is the thing almost everyone gets wrong here. The common perception is that these animals were flying dinosaurs, but they weren't. Pterosaurs were something else entirely. They were the first vertebrates on Earth to truly master powered flight. Long before birds filled the skies, these reptiles had already solved the problem of flying with bones, muscles, and wings. You see, for a long time, this was how we imagined Quetzalcoatlus, but that image kept changing. Over the years, Quetzalcoatlus has been rebuilt and reinterpreted by scientists many, many times. Each new finding has forced us to rethink the animal, its body, behavior, habitat, and even lifestyle. So from the time this fossil was first discovered, the same questions have followed it. What kind of evolutionary pressure could build an animal that seems to break the limits of flight? How can science be so sure of itself while studying a creature no human has ever seen? And perhaps the biggest question of all, how does an animal with such a disproportionate body get off the ground at all? In the late Cretaceous, around 68 million years ago, pterosaurs dominated the skies, having faced almost no competition in the air. They had existed for a very long time in their evolutionary history. The first pterosaurs appeared in the age of the earliest dinosaurs, and over the eras that followed, the skies filled with their many forms. From early flyers like Dimorphodon to the long-tailed Rhamphorhynchus, then Pterodactylus, the first pterosaur ever named by science, and later the great crested Pteranodon. By the time Quetzalcoatlus appeared, pterosaurs had already been in the sky for more than 150 million years. But this animal belonged to their final world, the last chapter before the asteroid changed everything. The end, when it came, was abrupt. The impact led to the extinction of nearly 75% of all species on Earth, including the pterosaurs. Its bones settled into the sediment and stayed there, untouched, for the next 66 million years. Fast forward to 1971. A geology student named Douglas Lawson was searching Big Bend National Park for dinosaur bones when he noticed an unusual bone weathering out of a sandstone slope. It was enormous, but strangely, it was also hollow and thin-walled, not like the heavy dinosaur bones he was used to seeing. At first, Lawson did not know exactly what he had found, but the shape of the bone pointed to something even stranger: a wing. More fossils soon began appearing at nearby sites. Some of the later fossils came from smaller individuals. Though they did not solve the entire mystery, but they preserved parts the giant specimen did not: pieces of skull, neck, and wing. Decades later, these smaller bones would become crucial for understanding the larger animal. In 1975, he named it Quetzalcoatlus northropi, after the Aztec feathered serpent god Quetzalcoatl and aircraft designer Jack Northrop. The name captured the strangeness of the animal almost perfectly, part myth, part machine. But after that, the science largely stalled. For decades, Quetzalcoatlus remained famous but poorly understood. It was talked about as one of the largest flying animals ever found. But the actual fossil evidence was still painfully limited. It was not until 2021, more than 50 years after Lawson's discovery, that a full and detailed description of Quetzalcoatlus finally became available. Despite this, scientists still had only a handful of bones from which to reconstruct the animal with confidence. The problem with Quetzalcoatlus, or any pterosaur, is fundamental. You see, fossilization is already an extraordinarily unlikely process. An animal has to die under the right conditions, be buried quickly enough, and then survive millions of years of geological change. For a pterosaur, almost everything works against that. Its bones were thin-walled and hollow, delicate enough to crush under the weight of sediment or scatter in moving water, coming apart long before they could mineralize. And Quetzalcoatlus had another problem: the place it lived. Its ecosystem was made of ancient floodplains crossed by rivers. These rivers overflowed and changed course constantly, churning sediment and rebuilding the land as they went. For preserving delicate bones, it was almost the worst possible setting. That is why the few good pterosaur fossils we have tend to come from rare, gentle environments. Quiet lagoons, still lakes, and fine mud that could settle over a body and seal it in place. Even when the bones remain intact, the majority of the specimen disappears. Wing membranes, muscles, skin, all of it usually rots away long before anything fossilizes. Typically, what remains are only remnants of bones, fragments of skeletons, skulls, vertebrae, or wings. But the missing material matters, because bones show the shape of an animal, not always what covered it. For decades, pterosaurs were thought to be bald, leathery reptiles. Then, a few rare fossils revealed a surprise. Their bodies were covered in fine, hair-like filaments, showing that they were not bare-skinned after all. Finds like that are uncommon. Most of the pterosaur fossils we have come from only a few locations around the world. As a result, every new discovery can change our understanding of these animals. You see, no body plan this large comes for free. Its size has to be paid for in food, energy, and the sheer effort of moving that much mass around. Evolution builds a giant only when the environment makes that size pay. So the question is not how big Quetzalcoatlus was, but what kind of world makes being this big an advantage. If a human stood beside Quetzalcoatlus, they would reach only about the height of its folded wing. The head and beak began far above that, at the end of a neck that carried most of the animal's height. And that shape is the strange part. In nearly every flying animal we know, from birds to bats to insects, the body sits at the center, and the wings extend from it in proportion. Quetzalcoatlus breaks that pattern. Its torso was compact, almost modest, while the head, neck, and wings reached far beyond it. And Quetzalcoatlus was not unique in this. By the time it appeared, this strange design had already been refined across an entire family of pterosaurs. The long neck, the compact torso, the disproportionately large wings. These were not quirks of a single species, but the signature of a lineage that had spent millions of years pushing flight in a very different direction. That lineage was the azdarchids, and by the close of the Cretaceous, they had spread across nearly the whole world. Quetzalcoatlus was the most famous, but far from the only giant. From Jordan came Aramburgiania, one of the first of these giants ever recognized. Canada had Cryodracon, the cold dragon, whose largest bones point to an animal on the scale of Quetzalcoatlus itself. The family even takes its name from a smaller cousin, Azdarcho, dug from the deserts of Uzbekistan and named after a dragon out of old Persian legend. And in China, Zhejiangopterus left behind some of the most complete skeletons we have, much of how we picture the whole animal today. They were not all the same size, but they were unmistakably kin, the same long neck, towering head, and the same body built. By their time, most of the older pterosaur lines had faded, and the azdarchids were left as the dominant flyers of the final age. See, we tend to imagine every prehistoric animal living together at once, but it was never like that. Tyrannosaurus lived closer in time to us than to Stegosaurus, with tens of millions of years between them. Pterosaurs themselves had been in the sky for more than 150 million years before Quetzalcoatlus appeared, and it arrived only at the very end, in the last skies before the asteroid. The world Quetzalcoatlus itself lived in was a low green floodplain, the warm inland coast of late Cretaceous North America, threaded with slow rivers and shallow water that spread and shifted with the seasons. For an animal with a wingspan like that, you might picture open sea and high cliffs. Quetzalcoatlus belonged to the soft, wet country instead. So where did it sit in that world? It shared the floodplain with some of the largest animals that ever walked, among them Alamosaurus, a long-necked sauropod stretching the length of several buses, along with horned dinosaurs, duck-billed herds, turtles and crocodiles in the rivers, and the great predators that moved through the same landscape. And on the ground, among all of that, Quetzalcoatlus was nowhere near the top of the food chain. Its prey was the smaller life around the water: lizards, amphibians, little mammals, fish caught in drying pools, and the eggs and young of larger animals, anything small enough to swallow whole. In the air, it was a different story. The skies belonged to the azdarchids, and over this floodplain, Quetzalcoatlus was the largest thing in them. And the food chain was not the same everywhere. On the island that is now Romania, where the dinosaurs had shrunk to dwarf sizes and no great hunters worked the ground, a heavier, thicker-necked azdarchid called Hatzegopteryx ruled, and likely sat at the very top of its island's food chain. Same family, same body, a different rung entirely, depending on who else lived there. By now, the outline of Quetzalcoatlus already looks impossible. But strange is the easy part. The harder question is how that body worked. A flying animal can become enormous only if every part of it makes the same bargain: strength without the weight. For Quetzalcoatlus, that bargain began in the bones. Those bones were thin-walled and hollow, fragile enough that most never survived to fossilize. But that fragility was also the point. Inside, they were not solid pillars. They were air-filled tubes, their walls, in places, thinner in proportion than an eggshell, braced by fine internal struts that kept them from buckling. It was the same principle an engineer uses for a hollow support. Remove the weight, keep the strength. That gave it a skeleton strong enough to hold together and light enough to fly. Birds run on a version of the same trick, so do aircraft. And this is what those hollow bones bought: an animal that stood as tall as a giraffe, with wings stretching close to 10 meters, weighed by most estimates only around 200 kilograms, about as much as 2 or 3 grown adults. Almost everything above the skeleton was air and thin tissue, a vast frame engineered to be carried on the wind. Then the wings, and the strangest piece of the whole design. Hold up your own hand for a moment. 5 fingers with a set of small bones inside each. A pterosaur's hand had those same bones, with one difference. It stopped at 4 fingers, with no little finger at all. 3 of them stayed short and clawed, tucked at the bend of the wing like a small hand it could still walk on. The 4th is the one that breaks your sense of scale. It grew longer than the entire rest of the arm, a single rod of bone reaching all the way out to the wingtip. Picture the ring finger on your hand stretched out longer than your whole arm, with a sheet of skin and muscle hung along its length. The membrane itself was a living, working surface. Running through it were thin, stiff fibers that held it in an aerodynamic shape under load. Alongside muscle and blood vessels, the animal could use to tension and reshape it in the air. At its leading edge sat a small bone found in no other creature, the pteroid, which the animal could move to change the shape of the front of the wing, much as a pilot lowers a flap to fly slowly without stalling. But we have to be careful here, because we have never found the wing of Quetzalcoatlus itself. Skin and membrane almost never fossilize, so the exact shape of that wing, how broad it was and how it tapered toward the tip, is reconstructed from the physics of flight rather than measured from the animal. Even the wingspan we quote is an estimate, scaled outward from a handful of bones. But a wing only matters after the animal is already in the air. For Quetzalcoatlus, the harder problem may have been the moment before flight. A bird can jump with its legs and let the wings take over. A giant pterosaur likely used a different system. Its shoulders and forelimbs were built to carry weight on the ground, and those same forelimbs probably helped throw the body upward during launch. And that changes how we should picture the animal. For all its ability to fly, Quetzalcoatlus was probably not a creature that lived endlessly in the air. day to day, it was a walker, moving on all fours across the floodplain and foraging along riverbanks, open flats, and seasonal pools. Flight was a tool it used when it needed one, to move between feeding grounds, escape danger, cross broken terrain, or get clear when rivers changed the land beneath it. And when it did fly, a body that large could not afford to flap for long. The cost would have been too high. More likely, it opened those long wings and soared, riding columns of warm air the way large soaring birds do today, covering ground for very little effort. Just how far it could travel that way is still argued over, and the honest answer is that we do not know. But the old picture of a creature that lived on the wing has quietly fallen away. First and foremost, this was an animal of the ground that could take to the air when it had to. Then there is the neck, and it begins with a mistake. When one of the first of these giant neck bones came out of the ground, it was so long and so hollow that no one took it for a neck bone at all. For years, it sat misidentified as a piece of wing. A long neck usually suggests flexibility. A giraffe can swing its neck because the bones have room to move. Quetzalcoatlus was built differently. Its neck was long, but held mostly straight. Most of the movement came from the base and near the skull, turning the whole neck into a rigid reach that could bring the head down onto its target. What kept that neck from buckling was hidden inside the bone. Scans showed hollow vertebrae crossed by fine struts, like spokes around a central tube. That gave the neck stiffness without adding much weight. At the end of that neck sat the head. And here, the honesty has to be sharpest, because we have never found a complete skull of the giant Quetzalcoatlus. The towering head we picture, with its long pointed beak, is scaled up from smaller relatives and from other azdarchids. It may be close to right, it may also be larger or smaller than the real thing. We are reconstructing the most recognizable part of the animal from bones that belong to its cousins. What we can say is that the azdarchid head was mostly beak, long, pointed, and entirely toothless, and built for grabbing small animals and swallowing them whole. We've already established what Quetzalcoatlus was not. It was not a dinosaur. But the more interesting question is where it actually belongs. Pterosaurs were flying reptiles, close cousins to the dinosaurs, but they belonged to a separate evolutionary branch all their own. If we see the family tree of the great reptiles, it splits so early, deep in the Triassic. One branch runs toward the crocodiles, animals still with us today. The other runs toward the dinosaurs. And somewhere near the base of that second branch, before the dinosaurs themselves took shape, the pterosaurs broke away and went their own way into the air. That makes for a strange piece of family history. Quetzalcoatlus left behind no descendants. The whole pterosaur branch ended when they did. You might expect its nearest living kin to be the bats, but its closest living relatives are the birds and the crocodiles. Within the pterosaurs themselves, the story falls into two great chapters. The first were the early forms of the Triassic and Jurassic, mostly small animals with long, bony tails. The sharp-toothed Eudomorphodon, the big-headed Dimorphodon, the fish-snatching Rhamphorhynchus, and the moth-sized Anurognattus, small enough to cup in your hands. The second were the pterodactyloids, the group Quetzalcoatlus belongs to, which rose in the late Jurassic. Their tails shrank, their necks and hands grew long, and the body plan fanned out into a strange variety. The fish-hunting Ananguera, the crested Pteranodon, the sail-headed Tapagerids, and the bizarre Pterodostro, whose lower jaw was a sieve of fine bristle teeth that strained food from the water like a flamingo. Between them, the pterosaurs reached nearly every corner of the planet, every continent, even Antarctica. Set against that whole long history, more than 150 million years of flyers, from moth-sized hunters to animals with the wingspan of a small plane, Quetzalcoatlus sits right at the tip, one of the last and one of the largest. You see, Almost everything we once believed about Quetzalcoatlus has, at some point, turned out to be wrong. Each picture held for a while, and each one fell as the evidence caught up. And that is the real story here, more than any single fact about the animal. The first scientists were not careless. They were reading a handful of crushed, incomplete bones, with no living creature to check against, and every reconstruction they offered was the best that evidence could support. What changed was not their care, it was the evidence itself, and the tools we built to question it. Today, a launch can be modeled against the hard limits of muscle and bone. A thin slice of fossil can be read for the growth rings that show how fast the animal grew. The same few bones that once gave only a rough sketch can now be questioned in ways their discoverers never could. The clearest case is the animal's own size. When Quetzalcoatlus was first described, the numbers were staggering. The earliest estimates put its wingspan near 15 meters, and some pushed higher. For years, that was the creature the public knew, an impossible, record-breaking giant. But as more bones surfaced, and as the methods for scaling them grew more careful, the figure came down. Today, it sits closer to 10 or 11 meters. Still extraordinary, still among the largest animals ever to leave the ground, but smaller than the creature first announced to the world.
It had a wingspread of 51 feet.
Greater than the height of a 5-story building.
The giant did not shrink. Our measurement of it got better. That one line is the whole discipline in miniature. The animal never changed. What changed was how clearly we could see it. And the same correction is still running. We have no firm agreement on what it weighed, and weight decides almost everything about how it moved, how it launched, how far it could travel on a column of warm air. The mechanics of that launch remain a strong theory, not a closed case. Its color, its voice, the way it raised its young, some of that may yet surface in new fossil, and some of it left no trace at all, beyond any method to recover. Which brings us back to the question this began with. How can science speak with confidence about a creature no living person has ever seen? It cannot, not completely, and it does not pretend to. The Quetzalcoatlus we describe today is the best reconstruction the evidence will currently carry, built from fragments, tested against the physics of flight and the bodies of living animals, and rewritten the moment a better bone comes out of the ground. It is unfinished, and it will change again. That is not the weakness of the science. It is the method working exactly as it should.